So hello everybody, it's really nice to be here to be able to talk to you today. My name is Emma Bowen and I am the MD and General Manager of IMS Heat Pumps. We are heat pump installers based in Scotland and England and have been around since around 1997. I'm also the Vice Chair of the Ground Source Heat Pump Association. So I am here today to talk to you about heat pumps. But before we get on to the actual technology, I just thought I would map out why you're hearing so much about them. Well, they've been around for a long time, but the view that the government and various drivers and legislation have all been gearing towards heat pumps as a standard technology has really started many years ago. So, you know, we had the Renewable Heat Incentive in 2011 and a variety of different strategy documents and legislation documents right up to recently where we've seen the heat and building strategy, changes to Part L and Part F in domestic and non-domestic buildings in 2021. And currently, you may be aware of the Future Home Standard consultation and the potential changes to the SAP proceedings with the new HEMS technology. In Scotland, very similar new build heat standard, heating building strategy with heat pumps firmly placed in the public domain. So all of that leads us to talk about the actual technology. So I just thought I'd touch on the differences because often heat pumps are all lumped together, but there are definitely two different types. There's the ground source heat pump. These are ideal for larger properties. You do need the land, but if you're talking about a small housing estate, then you know you've clearly got the ability to design these in at the beginning. In terms of these, they are best for new build properties where the installation can be planned in right from the start. They are more expensive to install just because of the groundworks element, but there's some really interesting moves in the market in terms of shared loop system and heat networks, especially for small estates or even large estates, and where the view that the pipe work in the ground is an asset on the balance sheet rather than an expense in the P&L. If you want to have more knowledge about that, Kensington Green Streets is a really good thing to have a look at. They are outstanding efficiency in that the pipework is buried below ground. So unlike air temperature, which is changeable, it's pretty much constantly 8 to 10 degrees, about a metre down. Obviously, if you're drilling, it's a lot warmer. And they are no external fan units. So in terms of any noise concerns, that's gone. Air source heat pump, these are the most common heat pumps that you're coming across these days. Obviously, excellent for property where ground space is limited. They are cheaper, less disruptive to install because of the lack of groundworks. So they are being used a lot in the retrofit replacement market. They do need more interior space than your average wall-hung boiler. In the trade, it's known as a plant room, but it could be, you know, something that shares with the utility room because you are going to usually put in a hot water cylinder and then some controls and various ancillary items. They're not as efficient in the winter as a ground source heat pump just because of the variations in air temperatures, but they are more efficient than oil, gas or LPG and much more straightforward to install given the lack of groundworks required. So when we talk about heat pumps myths, a lot of these relate to the air source heat pumps. And so I just thought I would touch on a couple of the top myths that we come across quite a lot. The first one being that heat pumps are noisy. So we just touched on ground source. They don't have the outdoor unit, but with the air source, they are an outdoor fan unit. And the public perception is that, you know, that's they're quite noisy. So we did this little video to try and demonstrate just how not.
Have you ever wondered how loud a heat pump is? Well, today we're going to find out. We've brought a specialist piece of equipment to measure the sound, which will measure the decibel level. So we're hoping that we can dispel that myth that heat pumps are noisy. It's actually working right now and I can't really hear it. How loud is the heat pump? Not
So it was interesting to note there that some of the bird song was louder than the heat pump, and that's one of the larger heat pumps on the market. That's an 11 kilowatt Aerotherm Plus, so it's a twin fan unit. But just to put that kind of noise decibel rating that you just saw there into some context, here's your decibel rating. You can see there your gas boiler flue coming in around 50 or 60 decibels. You saw there the heat pump working at full tilt. That's between 40 and 50. Your fridge freezers in that similar range when that kicks in. Your background noise of a library is around 29, 30. It's worth noting that obviously the full bore running of that is generally when it's colder outside, which I don't know about you, but I like to drink my gin and tonic in the warmth, where you're less likely to have that heat pump kick in. Most of the major manufacturers out there have realised that noise is a concern. And so they've all done their best to bring that down. And a lot of the heat pumps on the market now have got what they're known as a quiet mark for the quietness of the product. You'll find that though generally they're mainly in the range of 40 to 60 decibels. And as long as they adhere to the MCS 020 permitted development rules in terms of the sound output at the nearest listening point, then they pass planning as long as they meet all the other requirements. Heat pumps don't work when it's cold. Obviously, you know, the papers are full of freezing cold homeowners, but it's worth noting that this is the kind of test facilities that, you know, major manufacturers have in terms of putting them through their paces in cold weather. I brought this slide here. This was the heat pump sold per 1,000 households in 2022 across Europe. And I don't know whether you can see this, but the largest amount of heat pumps there were sold in the coldest countries. You've got Sweden, Denmark, Norway, Estonia, which, you know, I think speaks for itself in terms of a technology outperforming the market in the coldest places across Europe. Here, I've just brought some real life. This is from a NEBE air source F2040. We've got a few of these up in Scotland, which is notoriously colder than the rest of the world. We also have them down here as well, but this is some real life data. So you can see at -9, one of my directors, Alan Donald, his home was registering a nice 19.4. Over here, we've got the office at the weekend. It was not this weekend, but a weekend. It was -8.7. Office was on a setback, 18 degrees there. Suzanne, the sales director, at -5.6, 22.3 degrees in her property. So they absolutely do perform in the colder weather. And, you know, we've installed hundreds of these across Scotland. As I say, notoriously colder than Brighton. But of course, you know, they're too expensive to install. So I just thought in terms of that, I would give you a bit of an update of, or an insight into what makes up the cost. So the heat pump itself, the reason people talk about fabric first or well-insulated properties is because if you're paying to heat the first 4 foot of the outside world, it doesn't matter what is providing the kilowatts into that property. If you'll need a bigger one and it'll need to work harder and it'll cost you more to run. And it's the same with a heat pump. The capital cost of a 3.5 kilowatt is going to be a lot less than the capital cost of a 7 kilowatt unit. So the more you can do to insulate that property, the better in terms of the upfront cost of the unit. Hot water. We have to design hot waters to certain standards, which I'll come to shortly. But again, a lot of people oversize the hot water requirement of the property. Smaller cylinder is going to cost you less than a bigger one. Again, size the property. If you're building a 2 or 3 bedroom house, a smaller system versus, you know, 5, 6, 7 bedroom executive homes, you're talking more money for the install kit. And, you know, this is your copper pipe and your insulations and your ancillary items. And again, simple systems, getting involved in the design early so that, you know, we can design the simplest system possible is going to bring down the labour cost associated with that install. Complex systems, many zones, different heated areas, that's going to cost you more money. And of course, you know, the view that they're expensive to run. because they're always on is what we hear a lot of. Well, there's lots of things that are always on, and you'll probably have heard that, heat pumps are like a fridge in reverse. So your fridge is always on, but it only kicks in as and when the temperature inside that unit rises. So, it wants to cool it down. And it's the same thing with a heat pump. It's always on, but on the basis that it's just trying to maintain temperature, and it's got the fabric of the building up to its best thermal properties. It's only going to kick in when the weather outside changes and the temperature inside that property drops. Interesting, just to point out here, because we get a lot of queries, well, what if the electricity grid fails? How will I heat my home? Well, it's interesting to know that your gas boiler's always on in terms of, it needs electricity to function. A lot of people tend to forget that. But there's no denying that the cost of electricity at the moment is more expensive than gas. And this is why the efficiency of the heat pump is really important. So just to try and explain this slide here, what we've got is a C-rated property. This has got some estimated energy requirements. So you've got 10,000 kilowatts, 2,000 kilowatts of hot water. And what we've got here is some views of the gas costs on this property. So bringing in gas at 7p on a 92% efficiency, although a lot of boilers would struggle to reach 92% efficiency, but we'll give them the benefit of the doubt. What you can see there is the rough costs of heating the home in the hot water on gas. You can see here then that the most basic SCOP, and that's the efficiency of a heat pump. And that means that you, for every 1 kilowatt of electricity you purchase at what we've got here, 27p, it will provide you 2.8 kilowatts of heat. This is the lowest efficient heat pump that MCS would let you install under the boiler upgrade scheme. And what you can see here is that you are just about breaking even. Sorry, I'm up here. You are paying more for your electricity cost on this very basic efficiency. As soon as you get to somewhere around an SCOP of 3.6, so that's for every 1 kilowatt of electricity that you buy, you are emitting 3.6 kilowatts of heat into the property, you are breaking even. You are, though, always going to be better than oil and LPG with any of these technologies at the present cost. But what the industry is looking for, and what we're already seeing in the market, is cheap electric. It's called, or known as, closing the spark gap. And we've already seen a move by OVO Energy in conjunction with Valent heat pumps, where homeowners can be offered 15 pence a kilowatt for the electricity that the heat pump uses. And when you see the difference there, you can see that, that makes all the difference. But of course, as I say, this is your basic SCOP, and this is, your break-even SCOP. It is possible, and you can see real-life examples of heat pumps running now with bigger SCOPs than this. And this is just a sample of a few of the Valent screens that show you the COP and SCOP of heating and hot water across a few of our units. If you go to heat monitor and look at the open energy monitor chart there, you can see a variety of heat pumps in a variety of settings, all outperforming the SCOPs that I've highlighted here. So, what do we need to do to make sure that the heat pump is going to be sized correctly and run as efficiently as we can? Well, your heat pump installer needs to do an accurate energy assessment. So this can be done off plan, or if you're in the renovation market, you'll have people come out and see you. But we are looking for the total heat loss of the property on a room by room basis, the loss through ventilation, the U values of the material that you're using, what the space is being used for, what's the view of the people who are going to be living here. All of those things form the heat loss assessment that sizes your heat pump and your hot water cylinder correctly. So it's really important to engage with somebody as early as possible. If we can get involved at floor plan stage, then we can talk to you realistically about heating zones, the space and place, and the best way to get your pipe runs, floor heights and build-ups if you're going with an underfloor. All of these things we can plan in early, which will give you the view of a more efficient system than if we're trying to shoehorn something in lastminute.com. Space, place and layout, again, very important, as I've just mentioned. You know, we're talking about whereabouts in the property. You're going to be cutting the plant. So a couple of examples you can see here. We've got a dedicated room under the stairs. This middle picture in the top right is a much larger ground source heat pump. You can see the size of the hot water cylinder there. Much bigger requirement for hot water. Again, another smaller unit just popped into the corner of the utility room here. Ground source, you know, this is the kind of thing we're looking at when we talk about trenches. So how much land is it that you're going to need? Rule of thumb, 2 to 3 times the heated floor area of the property in available land. And we're not talking gardens, because you're not going to be able to build over the top of this. This has got to be arable land. You can car park, you can graze cattle, you can put horses, or you can just leave it as a field, but you can't build anything over the top of it. Again, just some more examples down here, manifold placement, whether you're going to be bringing in the drilling kit, and getting some examples of, you know, whereabouts you're going to place the outdoor unit if it's an air source heat pump. So hot water, touched on it earlier in terms of potential oversizing. We have to design to this BS 8558 minimum standard. That's based on 45 litres per person per day, plus one. But obviously there are some requirements for some properties in terms of bigger hot water requirements. Heating distribution, again, getting in early, where we're doing the underfloor, how much pipe is going in the underfloor. Pipe spacing is very important in terms of the design. Radiators, is that a first floor only? Is it throughout? What is the size of the radiator? Where are they going to fit? Where are the pipe runs going to go? And then talking about controls and how that system's going to be used by the end user. So just to give you a bit of a summary of what I've just touched on, given the changes in various legislations, energy efficiency on new build homes is not optional anymore. Part L now says all systems need to be designed at 55 degrees or less, which is a perfectly suitable temperature for running a heat pumps off. However, getting in early on a new build to current regs or better, we would be designing that property at 35 degree flow, which is a better efficiency for the heat pump and will reduce running costs. Ensuring that you get a balanced design by understanding what the property's use is, who's going to be living there, how they're going to control that, will give you a cozy home and is in a great investment. And on that great investment, we're all sat here, you know, is it worth it? Do heat pumps add value to your house? So the view here, a couple of things I've just pulled off the internet. Ground and air source heat pumps could increase your property value by up to 3%, which was a recent report issued by Scottish Power in collaboration with the World Wildlife Fund. And a recent report by Uswitch, homes with EPC ratings of A or B have increased value of up to £57,000. People are actively looking at more energy efficient homes and low carbon outputs for those homes specifically. So, yeah, if you are in the game of building new homes, whether that's small developments, big developments, one-offs, heat pumps are definitely something that will work for that property, and engaging with a great installer early on will give you the best return and result for that.
Well, thank you very much, Emma, for joining us at Show Home Live and for clearing up some of those myths around heat pumps. I do have a couple of questions. First of all, regarding the size, would you say that the size of the heat pump is dictated by the size of the property?
In general, yeah, that would be the rule of thumb. But it's interesting to note that it really is in regards to the insulated property of that home. A 4 or 5 bedroom property, super well insulated, not a great heat loss, could potentially have a smaller heat pump requirement than, say, a 2 or 3 bedroom home with minimum insulation standards met. The rule of thumb that has been in the industry for a long time was 40 watts. a square meter on a new build. We are seeing properties now with a requirement of 25, 30 watts a square meter, because people are really doing everything they can to make sure that the insulation properties of the homes that they're building is as good as it can be, and that will reduce the capital cost of the unit.
And going back to the myths that you did mention, the one around the fact that heat pumps are much more expensive, do you think this is due to a lack of awareness? And also, how do you think we might be able to make more people aware of the fact that actually they're not as expensive as they might have thought?
Well, there's no getting away from the fact that electricity is more expensive than gas at the current time, and that's by a factor of 3.6, 3.7. Other tariffs are available, and I know there are some innovative tariffs occurring on electricity use right now. But a well-designed, well-installed heat pump will absolutely save you money across a gas bill, and that is really where anybody who's looking at putting these on needs to understand about engaging with a good quality installer and engaging early to make sure that the design can be as efficiently done as possible, that the end user is in mind when that design is being done, and then ensuring that it's really installed well across both the distribution system and the heat pump. Our clients are saving money on their gas bills. It's a fact. So, and we're not the only ones. As I say, Heat Pump Monitor, Open Energy Monitor will show you a variety of heat pumps across the country outperforming SCOPs. Anything over, as I say, that 3.6, 3.8 is a money save on gas. And if you put in a small estate together that doesn't currently have a gas main in it, it's saving you a cost there. Soon you won't be able to request a gas main for a site, at which point your choices are electric or oil LPG.
And regarding the myth as well that heat pumps are noisier or very noisy, where do you think this myth actually comes from?
It's really difficult to say. My opinion is that we are aware of the usually commercial run air conditioning units sat outside properties. They're working really hard during the summer when we're out and about on the streets, and we can hear that. The permitted development rules were pretty much a copy and paste of the air conditioning unit rules. And I think that's kind of where it's come from. It's interesting to note that BISRA have really done a study, recently done a study into the noise of heat pumps, and the permitted development is currently out for consultation on reducing some of the boundary requirements, because the realization is that whilst noise is a major concern about heat pumps, the actual level of complaints about noise from heat pumps is minuscule. So I've deemed it the noise about noise, and where's that come from? But interestingly, the domestic heat pump manufacturers have taken those, issues on board, or perceived issues of noise, and all of them have worked really, really hard to bring the noise of the outdoor unit down as much as they can. I always like to say, even Dyson's not invented the soundless fan yet. Unfortunately, it does have to spin.
I imagine there will be a sort of domino effect. You mentioned that people might think that heat pumps are noisy because they've seen the large air conditioning units, and perhaps a similar thing will happen with heat pumps, that with time, more and more people will see that actually they're not noisy, and those that have them will also see that they're saving money. And then, with time, more and more people will become aware of this, and therefore more willing and more open to look at.
Absolutely. Unfortunately, Mr. Smith installs well-designed, well-installed heat pump, is saving money on gas bills and has no noise complaint, does not headline, clicks make. For every, headline of the man who is, re-insulating his house with cardboard because he can't afford to put his heat pump on, there's 1,000 homeowners who are sat quietly and enjoying their cozy home, saving money on their bills and not being bothered by the noise. But yeah, they don't make great stories.
Well, possibly with the, word of mouth.
Yeah, well, it is all about the awareness. Unfortunately, we haven't got a great, positive marketing messaging coming out of the various government departments. I noticed that they have recently just started campaigns on, having a better, efficient energy home. But realistically, that's what we need. I've been calling for a while. We had a lot of a campaign about make sure your analog TV became digital. Because you might not see EastEnders again, and we kind of need that about homes and the heating systems. Heat pumps do work. They're not noisy. There's nothing to be afraid of, and a well-designed, well-installed heat pump will save you money currently on your gas bill, and definitely in the future when they close that spark gap.
Yeah, I think it takes us back to the point of not just a lack of awareness, but raising awareness, and hopefully some of the initiatives you just mentioned will be more common, and therefore the word will get around faster that the benefits to the heat pumps.
Yeah, well, I mean, as an SME in the business, we are roundly positive about the people like Octopus and Era and EDF getting involved, because they are large companies who are banging the drum to say that this technology works. Don't be afraid of it. And they're the ones who've got the larger marketing budget. And in the absence of, a positive single message out of government on that, their marketing budget will do. And, it's interesting to see, because in Scotland, the landscape is quite different, and that messaging is really there, as is the support. And interesting for anybody who's on the meeting, who's looking at just doing their own individual build, then they are eligible for both the Home Energy Scotland loan in Scotland and the boiler upgrade scheme in England. If you are building your own home to live in as a self-builder, you're eligible for funding under both of those regimes.
Well, thank you for pointing that out. I think that's very interesting to note. I did want to ask as well about the level of maintenance required, because obviously we're all aware of the fact that boilers need to be checked. What's the story when it comes to heat pumps?
So a heat pump, set up and run and left to its devices, should happily function. Your warranties require an annual service on the heat pump. There are a few things a homeowner can be taught in terms of just making sure that things are chuntling along in their best and most efficient way. But having your eye on an engineer coming around and making sure that is as efficient as possible is still a good thing. And as I say, it's usually led by warranty requirements on the unit. Interestingly, that outside of just your heat pump service, the unvented cylinder that goes alongside it, there is a requirement for that to be inspected for G3 regulations on an annual basis. So definitely worth having somebody come out and do both for you.
And just to finish off, Emma, why would you recommend that house builders or developers choose a heat pump over, let's say, a boiler that could run on green energy?
Well, the view that hydrogen for domestic properties on a large scale, I think, has been now roundly kicked off the table. The recent trials in both Whitby and Teesside have been cancelled. And I believe that even the government have now accepted that, even a 20% blend of hydrogen is too expensive and is actually not as green as you would be led to believe. The alternative then brings you to oil, LPG. It's a tank, it's deliveries, it's more vans on the road, which leads you then to like a direct electric approach. Direct electric, absolutely, it's as low carbon as a heat pump, in the sense that if you're using a renewable electricity tariff, it's zero emissions at point of use. However, you can't get away from the fact that an electric boiler is a 1 kilowatt in, 1 kilowatt out scenario, whereas a heat pump, 1 kilowatt in, 3, 4, 5, 6 kilowatts in some cases heat output, and the efficiency of that wins hands down.
Well, thank you very much, Emma, once again for joining us at Show Home Live and sharing that very useful information.
Not a problem. It's been an absolute pleasure.